a few other very basic comments on modeling process. And these are things that I feel I need to tell you. And I've said this maybe each day of this boot camp, but I need to put it in black and white and to make it available to you as slides and make sure that it's really emphasized this last day. And that is the virtue of incremental model development, of building a model step by step by step by step. The general rule is start simple. Start with a model that's got an absolute minimum of things, and then add things in logical chunks that sort of go together, but of one thing at a time. That's sort of, and that may mean, a variable and a graph that uses it, and the transition which updates that variable, what have you. But then run the model. Now, it turns out that this incremental model development, as I've tried to emphasize, confers great value along several different dimensions. So the idea here is that each iteration, the model is modified in some small fashion. And critically, we can compare the new version of the model against older versions of the model. And often you will do this by making sure the behavior of the two versions is the same with the new feature turned off. Make sure you haven't broken anything that was there originally. And then you turn it back on and see what the difference is to understand the behavior, the differential behavior, the new behavior with the new feature enabled. And often these incremental versions could be shown to people, maybe if not external stakeholders, at least those who are other team members, and very importantly can produce insights that inform the choice of what next to undertake. So here's a number of benefits, and you'll see that they cut across many areas. One of them is understanding where a given model pattern emerges from. Often we'll have a big model at the end, and if we haven't built in a step-by-step way, we're not sure where certain aspects of behavior that we see come from. Worse yet, we're not sure if those are bugs or features. Are those emergent behavior that's really interesting, or are those instead just bugs within the system that have gone latent? It's hard to tell if we have a big model, lots of moving parts, maybe built by someone else. It's hard to tell. If we've built it step by step and we see some funky behavior come in, we can quickly track down what's going on much more quickly because we've only changed a couple things. So all we have to do is look at a couple of things to sort of see where this might be going on. And it's a lot easier to spot those bugs that way. It's a lot easier to spot a defect. Conversely, it's a lot easier to know what exactly is causing this puzzling behavior. But additionally, and critically, there's this ability to learn and to change what you do next based on what you observe. So maybe you see something really unexpected, and you say, wow, that's really interesting. We should really focus on that for the next few iterations, because that itself seems to be promising for a paper or for informing the policy discourse or what have you. In which case it takes a different direction. Maybe a year from now you do have a bigger model with lots of pieces, but it's a more informed model, a model that's sort of more that's learned along the way in terms of what it includes. You can also sometimes secure feedback from stakeholders in these new versions. You can say, look what just happened. Could you help me understand this? And get that feedback on an ongoing way. Often it leads to greater clarity and prioritization. You can spot early if something's if the model is sensitive to things. You can more effectively time box. This is important. If you plan for a year from now, we're going to have this great model. It's hard to know, are we going to be able to do it within the year? Software developers and model developers are notoriously poor at estimating big chunks, how long it will take to do a big chunk of work. You can just fool yourself so easily. You forget about, you're going to be out of the office 2 weeks for this wedding. You need to take vacation, you're going to be away for this conference. And it's really easy to fool yourself what you can do in 3 months or 6 months or even worse, a year. It's really easy to overimagine what you'll be able to do. And there's a big literature of this sort of stuff in software development about how terrible we are at estimating big chunks of work. We tend to be much more effective at estimating how long it will take to perform small chunks of work. If we talk about a certain feature, you will be thinking in very concrete terms. What exactly do I need to do to add that feature? What are the key uncertainties associated with it? Like I need to learn about how events work, or this dynamic event thing. I need to spend some time. Oh yeah, and tomorrow afternoon I'm out because of this training, and later in the week I'm going to be working on this other prioritization thing, this other aspect of priority. And so you can be much more effective in estimating when you will get it done. Very importantly, though, this is key. All along the way, you will have a working model. Something in hand. Whereas if you say, I'm going to build this a year from now, and you're building up to it, and you don't have a working model along there, if you're just adding things in and trying to configure them, then if you have to stop partway through, or if an important stakeholder says, I want to see what you're doing, you don't have a running model you can show them. At least this way, you always have something in hand. Even if it's not as grand as you'd like, you have something working, something that you understand, something where you are confident it isn't chock-a-block full of bugs. And it's a sad truth, but there are PhD dissertations that have been derailed by building the bigger, better model. It's so, particularly with agent-based model, it's so flexible. You can throw things into it really easily. Oh, let's have this, let's have that. And then when you're, a year along the way, you have this model. Maybe it runs, but there's evidence that it's buggy. It crashes sometimes when you run it overnight. It gives this odd behavior. You have no confidence about whether that's due to a bug or due to some emergent behavior. It doesn't have all the features you want, and you never thought it would take this long to build it, and you are not feeling good about the project. So building it up bit by bit by bit gives you so much more confidence, so much more in hand, and so much more in the way of learning. And it does enhance the confidence of stakeholders. It improves your morale. You're feeling you've got something there. Well, yes. Great. So you mean by adapting, you mean there's a pre-existing model that's been built, and you want to, for example, port it into or place it into any logic.
It's very well aligned. It's already in any logic. It's very well aligned with the purposes of what we need a model.
Yeah.
But going in then and adapting it to what our specific situation
is.
So maybe it's a different geography, or
right.
It speaks to perhaps what data is being used.
Right. In our area. Okay. Sure. Well, what I would do in that case is perform that adaptation in a incremental, step-by-step fashion where you make one change, you run the model, and even though now you've got a kind of weird Franken model where it's half one region, half another, at least you can observe the behavior and see, okay, something horribly broken, right? Is something really off. And I would start with the ones that you think are maybe most important in governing dynamics, so that you could, or in influencing the dynamics, so that you could see the change from that in a very clear way. And you will learn along the way about what's really sensitive. And, that may inform how you end up spending the remainder of the time, because, you say, well, this data from this other region isn't quite in the right format. Let's try putting it in this way. But we could spend a lot more time going back to the data source to get additional data, but we don't know how important it is. So you get this in the model, and then using the technique Kurt has arrived to talk with you about, you could perform sensitivity analyses and see, how critical is refining this data likely to be to the outputs we care about, or even more so, the trade-off between interventions. Yes, Kurt.
When I say nature, I don't mean the complexity of the model, which is obviously part of it, but how much confidence you have in that model, and what area. Every model sort of has its story. so if you have access to some of the teams that built that original model, or members of the team who built it, then it might be helpful